For those of you that weren't there this morning, this is me. This is an airplane that I purchased earlier this year. Yeah, I know, that's like, okay, what the hell? Not meant to be a flex. It's a 1968 Piper Cherokee. For those of you that don't know, I am a student pilot. And where I live, it's kind of slim pickings as far as trainers, so I ended up figuring out a way to afford an airplane. Now, being in aviation and learning about aviation, it's been kind of impressive to me what you learn. So for those of you that were there this morning, I talked about the FAR AIM and their regulations, and it's a subset of all the regulations, but the book is like this thick, right? And as I'm looking through this, I'm reading this, I'm looking at all the ways that the FAA and the NTSB work together to understand aircraft, how they manage it, and things like that. And I started seeing the parallels to how a lot of organizations are trying to deal with open source, how our government is trying to do things to influence how we deal with the construction of our software products. Because you see, this airplane, one of the things that the FAA mandates is that every aircraft that is ever shipped has this minimum equipment list. And what that list is that's basically everything that's installed in my aircraft other than the airframe itself, okay? And the reason they do this is so that, some of it's for weight and balance reasons and whatever, but as you make modifications to the plane, you can track what components you have in there. As issues come up and the FAA releases what they call an airworthiness directive, again, they can go back to this list and understand from this list and then your records what you have installed in your plane. Great, cool, wonderful way that if, it turns out that, I don't know, the wings on one of these airplanes falls off, true story, that does happen, it negates a certain kind of inspection, and they know who has airplanes that who are affected by that, right? So are you?
I'm so sorry.
No.
Sorry to interrupt. I apologize. Is anyone here playing a game? Okay. Anyone here in the featured session happens to be participating in gamification component of ATO? I need to give you a code, okay? I apologize for interrupting.
No, you're good. You're good.
Anyway, it's
FEAT10 is the code. All right. As opposed to FEE10, which would be something that probably doesn't smell as good. No worries. So, I started seeing the parallels, and then, we had one other thing that happened. I mentioned this earlier today. This is the 737 MAX 8. Most of us understand the story behind this, but basically what happened here was it's very expensive, right, to build an airplane. And when you build a new version of an airplane, it's even more expensive because you have to go through this whole certification process. Think of that akin to what we do with regression testing. So I get done, I build a new form of airplane. I have to go to the FAA, they have to do all sorts of testing, certification, all this stuff, right? And it's a long, involved process. So when Boeing was making the 737 MAX 8, they did everything they could to keep it a 737 because that meant they didn't have to recertify it. They didn't want the expense of doing that regression testing. So among other things, when they moved these engines to a different position, they had to account for the fact that the plane now performed very different. But they can't make design changes, so what did they do? They made a software change. What happened? Well, there actually wasn't anything wrong with the software. Software worked great. Problem was a piece of hardware failed on these planes, and because the redundancy of that particular piece of hardware was an option, a lot of people bought it without it, and suddenly we had, 3 instances of these planes basically taking control away from the pilot and crashing themselves. So you can see the parallels now, why this brought me to how we deal with open source, how organizations deal with open source, and how there's some lessons we can learn from what the FAA does and how the NTSB works with the FAA on that. I'm not suggesting we turn our software management into the FAA form of regulation, so don't take it that way because that would be a nightmare. But so we're going to dive into that. But first I'm going to tell you a little bit about me. I didn't do this earlier. So first and foremost, I'm a hacker and a researcher. I've been a hacker my whole life. I bought my first computer when I was 12 years old. I hacked into Prodigy. Some of you in the room know what I'm talking about. Some of you in the room have no clue. When I say Prodigy, you're probably thinking of the, there's like an education services thing out there now that does that. We can talk another time about what Prodigy was, but got into tech at 19 during the dot-com era. I was still in school in a computer science degree and started as a programmer. I worked in financial services for 10 years as a software developer. Since that time, I transitioned from that into security first as a pen tester, and then it's kind of escalated from there to the point that you see now. I am the CISO for a company called Epiq Global. And just to be clear, everybody in the room knows that it obviously is not the gaming company, that obviously is not the healthcare company. We do legal services. That's fun, or not. But that's where I'm at. So the point of all that is just to let you know that I grew up in software development. I grew up in application security, and I have a bit of a passion for how security treats developers and how poor a job sometimes we can do at that. Some of the things really quickly, I'm an author and a blogger, more of a, I don't know, it's probably out of date at this point. Most of my blogs are fairly old, but I did just release a book earlier this year. And then finally, as I said, former software developer. That's why I care about open source. That's why I'm here. And that's why I want to talk about some of these things, because as I mentioned, we have another example of where open source security and vulnerabilities and all this talk of vulnerabilities in open source have gotten to that point that it's really sapped our developers, our engineers, and our maintainers a little bit of some of their energy. It starts, we can go back, and open source has been an issue as long as I've been in this industry. I can go back to the early 2000s we were talking about. Then the idea was, well, do we ban open source from our development environments? Anybody ever tried to do that? That's the reaction I'm looking for. I know people who have tried. It does not work. You're not going to do it. Let's face it. Most of us in this room understand what the open source ecosystem looks like today and how we develop software. That 80,000 lines of code in your application, yeah, you probably wrote 10,000, and the other 80,000 or 70,000 came in packages. So, we started seeing breaches. The first really big one that really pointed a finger at open source, though, came with Equifax. And this is about 5 years ago now, almost 6 years ago. And it was just a vulnerability in struts. Okay. CVE was logged. We knew it was out there, and somehow Equifax still missed it, didn't realize they had it in all the places they did, and it affected 164 million customers. Now, I've seen plenty of discussion arguing about it, and I'm certainly not going to argue the merits of, did they do the right thing or the wrong thing, but the fact of the matter, let's be honest, it's hard as an organization the size of Equifax in particular to know everywhere and every library that your developers are using. So what do? We typically, we have a notification comes up, we scramble the jets, get everybody involved, right? I mean, after all, that's what we did with this one. How many of you dealt with Log4j again? Most everybody in the room. Wow, we have a lot of Java developers. Look at you. So, and that's exactly how most organizations handled this. Log4j came out, there was no formal disclosure. I mean, it was literally some kid hacked Minecraft using the vulnerability. Like, good for that kid. I still want to meet that person. But, this thing comes up, we create this cool logo, if you call it cool. Somebody got bored quick. I think it might have been Kevin Beaumont who actually made this in MS Paint. But, And we find out, okay, well, there's a CVE, and it's critical. It's an RCE that can be exploited over the internet and gain control of your system via remote code execution. And then, oh, wait, there's another one. And then, oh, wait, there's another one, right? So as we've got maintainers scrambling now, because, of course, the pressure's on them to fix this, it took a couple iterations to get it right. We also had every attacker and every security researcher in the world now taking a hard look at Log4j. So what do we find out? We find out 91% of Java apps had this vulnerability. But the scary part, going back to the Equifax thing, is that 61% of those came through indirect dependencies, where my software included a library, and that library somewhere in its dependency tree included that vulnerable Log4j. So most of us probably have a little bit of traumatic memory of that from last year. And then Spring for Shell came along, and we're like, oh shit, here we go again. Here's our CVE, here's another CVE, here's another CVE. Same story, right? Only this one turned out to be less critical. It wasn't even as bad as Log4j, but coming fresh off of that, we fired up the troops, got everybody involved, all hands on deck. Let's get everybody in there. And what happened? It was never even exploited. There are no known exploits of that. But we paused developers from doing their jobs. We slowed everything down because we had to fix that vulnerability. Which brings us to today. How many of you have read the release from OpenSSL this afternoon? Spoiler alert, we've downgraded both to high. They are not critical. And they specifically affect X509 certificate validation. How many people are rolling their own X509 certificate validation? Exactly. There's like 3 people in the room. My condolences. Or maybe it's cool. Maybe it isn't really cool. I shouldn't assume, right? I shouldn't assume. But that just sounds to me, I'll admit it, I'm awful with cryptography, so it just sounds brutal to me. But yeah, so here we went again. And there were people out there, people I respect in cybersecurity, who claim to have insider knowledge of this, who were like, yeah, this thing is really bad. Well, something happened between them saying that and where we're at now. I don't know. I don't know what changed. I'm not going to judge, all right? I'm not judging, but what I am saying is this is another case where security got all giddy and fired up and got everybody, I mean, I did. I had colleagues of mine that I trusted telling me, yeah, this thing looks really bad. I've got teams on call who I just, in the minutes before this talk, had to basically tell them to stand down. Because, okay, we got some mitigations. Right now, we don't have this identified anywhere in our environment. We had this huge inventory of all the places we were using OpenSSL, but guess how many of them are doing X509 validation? None. So these are the things that frustrate me. So I mean, let's talk about it. Like open source, we understand. I'm preaching to the choir here. We've got in the open source community something I think is amazing, something that when I was a developer, I would have loved to have had. And that is just the level of open access that we have to open source software. We've got package managers like Maven and others that give us this capability to not have to reinvent the wheel, what we call reusability, or there's 100 different names for it. In my day when I was a developer, that was the thing, code reuse. It was all about code reuse. If I was developing software for my home banking application that I worked on, it was, how can we use those same modules elsewhere? Or how can we avoid writing that over again if maybe we can pull that from somewhere else? What are those common tasks? Open source, the open source community and this ecosystem we have today is, I mean, I'm kind of jealous of people who are first entering software development now because of that part of it. I'm not really jealous because y'all have the more complex environment than I could have ever imagined. But this is the world we live in. I can pull code from anywhere. If someone's got it up on GitHub, and it's public, I can pull it into my through my package manager most times. I can get it into my code. I mean, what could possibly go wrong with that? It's great. How many of you remember the arguments about whether or not open source was more or less secure than proprietary code? Were you all there for that? Right? And go to Reddit, you'll still see it. Like, they still argue this to this day. Oh, open source will be more secure because everybody's looking at it. Yeah. But then we also have, a single maintainer who writes some cool little utility thing that they just needed for one thing, and suddenly the world loves it, and there's, 8 million pull requests on this thing. Like, oh, yeah, it got popular fast. So, it's a complex environment, and it puts us in a position where, we've got a lot of different people who have their thoughts on how we should address this. First to the room, of course, is InfoSec. That's where I come from. All right? Anyone recognize that, by the way? You know where that's from? No? Ah, come on. We'll get there. But, so, this is my world. I work in InfoSec. I watch my peers and colleagues get excited and pontificate, because I do it too. I'm standing up here telling you all this, right? But InfoSec has certain motivations when it comes to how we deal with open source. Like I said, there are some CISOs out there today who will still tell you that they have banned open source from their environment, which comes with the uncomfortable conversation about, you just don't know it's there yet. It's there. So when I think about this in terms of going back to my metaphor before, remember I mentioned the FAA and how they manage significant changes to your aircraft. You have to log this form. This is a 337 form with the FAA. It says, hey, I've made this modification to my aircraft. And an AMP, airplane and power plant, or airframe and power plant mechanic signs off and says, yes, this is correct and well and good. So you have all this traceability. Well, that's what security wants. Security wants to know, how do we trace everything that's there? How do we know when it changes, and how do we get alerted? So we have a bunch of really cool tools. We have these cool tools we call SCA, Software Composition Analysis. I love these tools. Quite honestly, in fact, I actually just found out today that if you are a maintainer and you have a independent project, meaning you're not corporate sponsored, Sneak will actually give you a free enterprise license of their product. So they're actually upstairs if you want to go talk. I just was sitting in a room earlier with one of them, and they'd mentioned that to me, and I actually thought that was worth sharing with the group because there might be some maintainers here. But the whole idea of these tools is to look at your dependency tree, walk it all the way down through 20 levels perhaps. Now you can accomplish that. There's dependency checkers and different IDEs and such, and you can do it there too, sure. These tools, they give you a little bit more. They do it more automated. They integrate into your CI tools. They integrate into your repos, and at the end of the day, they give you a list of here's everything you got, and if a vulnerability shows up, they say, hey, guess what? A new vulnerability was released in this package you got there. It's great. Okay, so we know what security wants. Security says, hey, just, how do we do this? So where this gets really interesting for those of you that aren't aware is the United States federal government thought this was a great idea, and they started talking about SBOMs, software bill of materials. And if you do business now with the United States government, you're required to generate an SBOM, something that tells them every piece of material that went into your software. Yeah, so when it comes to open source now, and I'm thinking about my dependencies, that's a nightmare. And the chances are we're only going to see that expand. I don't think the SBOM is going to make it out of the public sector, but this type of thing, I'm already, as a CISO, starting to see the security questionnaires come in from my customers asking for essentially an SBOM. But then SREs entered the chat too, because we have this thing we call DevOps, right? Devs in it. our engineers and our operations teams were all supposed to be working together, and SRE's kind of saying, yeah, every time one of these comes up, you throw it at us, and we got to go out and patch it everywhere. And that happened with a lot of organizations with Log4j. I'm like, how do you get your SREs involved in this mess? Well, because they support this, and we're using these containers and these base images, and they have that version of Log4j. Okay, it makes sense. But we're supposed to be creating alliances, right? The airlines have figured out how to do this. This is what DevOps was all about. It's so interesting. It's kind of fun because you ask somebody, just go up to some random person at a developer conference, ask them what DevOps means to them. You get a lot of different answers even today. But I mean, if you go back and you look at where this started, was it 2008, 2009? Patrick Dubois and Andrew Schaefer got together and, hey, we have this really cool idea. What if we stopped fighting and creating silos and we just work together and we all have the shared responsibility to get software out and make sure it's stable? What if we all work together on that? We break down all those barriers. That was the point of DevOps. And so when security thought, oh, that's really cool, get us involved. But what did we come to the table with? We came to the table with a lot of tools, because that's what we do in security. I mean, that's what we do everywhere, let's face it. Tools are great, but we came with a lot of tools that didn't really speak to our developers. And that's an issue. And this is where that hyper-focus that happens so often on DevOps, where people are like, DevOps is all about automation. We got to automate everything. That's one piece of it. But security thought that was how we're going to get our tools into the pipeline. We'll just automate them. But then we figured out they don't automate well. How do you take a DAS tool and automate that? That thing, it's going to open up an application, log into it with some credentials you provide it, and it's going to crawl the application and know all of the things that it should fuzz and all of the input parameters it should be testing. And it doesn't work out. So when we think about DevOps, we've got to be thinking about how are we breaking that down. Now, incident response would like to join us in the room too. Incident response is usually security, but not always. But what do we do when something like this comes up? In the FAA, we have this thing they call an airworthiness directive. Remember I mentioned the wings falling off planes before? Again, a legitimate problem that happens with Piper aircraft. Can't make this up. So what do? They release an airworthiness directive, which basically says every person who owns this type of plane from serial number X to serial number Y has to take these actions. And with those planes, it's different levels of inspection. We don't really have that when we start talking about security and we start talking about open source security. You want an example, take this OpenSSL thing from today. The OpenSSL project has a very specific set of procedures that they follow. Those are their procedures. They follow them. Other organizations, other maintainers, other groups, they all do it differently. Some don't have any policy or process at all. So we've got our incident response people who are out there looking for some type of process. Now, what was really cool with Log4j, my experience with Log4j, was that we had one of those SCA tools in place. So when this came up, our process was pretty simple. We've got this alert. We run an inventory out of, I think we were using white source. So I'm trying to be equal opportunity here. I talked up Sneak before, now I'm talking about white source, okay? But no, we had a list within hours of all of the vulnerable targets that we needed to be concerned with. Now imagine the value for your incident response team when you can provide them that. Now the really cool thing with this, because of the way that these tools work and because that they're written for developers, is they plug into my repository, my engineers, this didn't slow down the CI at all. CI/CD pipeline was doing its thing. The tool, white source, would just analyze it when they committed code to the repository. And you know what we didn't do? We didn't break the build when it found a vulnerability. And we'll talk about the importance of that later. But, hours into this, I had this whole list. 2 weeks, we were fully remediated. I'm talking to my colleagues, my peers, 2 weeks later, and they were still trying to figure out where they even had this thing. So there are solutions there. What about compliance? How many of us love compliance? Yay, I have one person. I love compliance. I love compliance because from a security perspective, they sometimes can be I don't like to swing a hammer, but every so often I need one. And compliance is a really cool hammer to swing, especially if I need to motivate my peers in the executive leadership team, right? Sometimes if I can get compliance to say, yeah, this is a thing, suddenly I get them to listen. I would much rather they listen for other reasons. But so compliance has joined the chat, and well, that's usually what happens. We run away kicking and screaming. But compliance is a valuable tool if we understand what compliance can really do for us. So back to the aviation world, it's all about learning from our mistakes. When there's a crash, the FAA and the NTSB get together and they release a report. And that report is detailed. I mean, it's got everything in it. It's got witness statements, it's got video, if there was video of the crash, it's got all sorts of analysis. It takes forever, I'm not gonna lie. Some of these take years to get to a final report. But the fact of the matter is they put all of the facts out there. They put their analysis and their conclusions out there in the public sphere. Why? So that when a 787 MAX 8 or 737 MAX 8 crashes, they recognize that me flying my tiny little Piper Cherokee 180 still might be able to learn something from that. And this is where the idea of having metrics comes into play in our organizations. And when I'm talking metrics, I am not talking about this idea of here's how many releases we had, here's how many, no. Metrics are there to help you tell a story. So tell the story. If you got into Log4j, for instance, and it took you 2 weeks to identify your targets, it took you 2 months to remediate all the internet facing, and then it took you another 6 months to remediate the rest. What's the story behind that? Those are important numbers. But what's the story hiding in there that actually matters? What are you going to learn from that? Hopefully what you're learning is maybe we prioritized it that way, and that was a good thing, and that's what we expected. Maybe 2 months was way too long, and we took that long because we had to pull developers off other projects, or we had to, we didn't have source code. God, I heard that one. We didn't have the source code for that app anymore. Where'd you put it? Is it under my desk? I mean, but seriously, these are the things that happen. So how are we learning from that? That is something that we need to be adding into this process. And that is not just on our engineering teams. That's not just on our operations areas. That's not just on our information security teams. That's across the board. But that's where getting back to having that process is key. Because at the end of the day, guess who else wants a word here? Your customers. Whether you're a maintainer and you're dealing with your customers, are those anonymous people who have, set up a dependency on your cool little text parsing package, or, whether you're an organization that's using open source in your tooling and you're producing software that your customers are using, they all want a part of that because at the end of the day, there's value to your business here. Someone is looking for money somewhere. Now, if you're a maintainer and you do this out of the kindness of your heart, I love you. If there is no value to you from open source other than, hey, I love creating software and this is out there, great. Somewhere, as you know, someone is using your software to profit. So that's a part of it. And what that means for maintainers is we unfairly get expected to meet certain levels of preparedness and security posture and so forth. So we need to understand where those pressures are coming from and what our duties are or are not. Because I'll tell you what, there's nothing more frustrating to me as a CISO, and I stress that for a reason, as someone in security, there is nothing more frustrating to me than an organization who is willing to use free software that someone produced and not willing to contribute back to that software when they find a bug. As an organization, how hard do you make it on your developers when you're telling them basically you want them to go to the maintainer and demand a fix to a bug? Write it yourself. You're part of the open source community if you're using it. You don't have to have your own open source repos, your own packages out there in the public sphere. If you're using open source, you're part of the community. You need to be a part of the community. I'm glad that we have some of our organizations who are beginning to understand that. There are still, unfortunately, a lot of organizations who look at it, and legal teams will stand up and say, I work in a legal company, by the way, who will stand up there and say, well, that we lose protection of our IP, or we could be held liable. No. The latter has been patently proven untrue. And the former, well, what are you doing with your IP that it would be exposed if you fixed somebody else's software? Interesting questions. So ultimately, it's all about the pipeline. And I said something this morning that I know, and I said it again here, and that is the importance that whatever we do from a tooling perspective has got to integrate into our pipelines in a way that's non-obtrusive. The idea of creating quality gates, things where I check in code, and if that code gets scanned by a static analysis tool, and if it finds anything that's above a CVSS 8.5, I'm going to break the build. True story. Well, that breaks your pipeline. The CI/CD pipeline is meant to flow in one direction, from your user story to production. Anything in between that forces it backward, says, hey, we got to this stage, but now we're going to go back 3 stages and do more development, is breaking your CI/CD pipeline. The maturity of your CI/CD pipeline, which we'll talk about in a second, is crucial. So we need to be looking for tools that integrate. Now, the good news is a lot of these tools are available in your repositories. If you're buying commercial tools, they integrate with your repositories, unless you're using something really obscure. I will say there are a few that we still run into. But, looking at how can I even just leverage free tools available to me in my repository lets me do one very important thing. And this is the part that will eat your security people up. It lets you focus on strength, not perfection. So those of you that were in the keynotes this morning, you heard me talk about this. This is crucial. The idea that I don't need to fix log4j in every single place it appears. Why? In many of those cases, that part of log4j, those Jindy requests, that wasn't even reachable code. My app didn't even use that. And it came in, it didn't even make it to the library. It never got that far. Or maybe it's on an internal network and it's accessed internally, so is it a risk? Yes. Is it something that I have to fix right now, today, with all hands on deck? Probably not. Do I also probably have other tools I could use in the meantime to watch for my employees if they try to exploit? Probably. So the key with CI/CD pipelines is making them more efficient. And if there's one thing you can take from this, whether you're in security, whether you're an SRE, whether you're a developer, whatever your role in software development, the faster and more efficient your pipeline is, the more secure you will be. And it drives security people crazy when I say that. And I know I probably have security people in the room who are like, Alyssa, what the heck is wrong with you? Because I've had these arguments. But the fact of the matter is, take the quality gates out and yes, release to production with a known vulnerability. That shocks people when I say that. There's a CISO up there who just said that we should release software with known vulns because she lost her mind. Here's the thing. The whole point is CI/CD, just like any of your other bugs. How many of you in CI/CD environments release with known bugs? Probably every one of you if you're in CI/CD, because that's what it's about. That is the whole tenet of how that's supposed to work. Continuous integration, continuous deployment. If I deploy something that has a bug in it, I come back and I fix it in the next one. If it's bad enough, I make it a P1, I stick it on my backlog, I know that it gets fixed in the next cycle. That's what we need to be focusing on with security vulnerabilities as well, because now we take it out of that mode of all hands on deck, and we can just do it as business as usual. And we need to be focused on resiliency. In our software design, I know this is a buzzword that we're probably all already sick of, but let's put some context in what it really means. What I'm talking about, and I hate, as a security person, I loathe the castle metaphors, but I'm going to use it here. Because this castle, this is Dover Castle in the UK, and what you see here is an interesting design feature that was common at that time. And that is you've got this huge fortified structure in the middle, right? That's your keep. That's where they put everything they cared about. So when you think about this from a design perspective, and I'm designing my software, how do you create that keep? Is that your data? Is that access? What goes in there? And how do you put that in the most fortified structure? But then what you see around it are the layers of defense. You see multiple walls. The walls are meant to be active defense, right? That's the thing that's going to stop somebody getting in. Well, no, it really doesn't. It slows them down. Those big yards in between each wall, they do two things. They slow them down, and they give you time to respond. Oh, they breached the outside wall. I can see them coming across. I have time to respond. I have time to take action against them because they have to cross. That's what mitigation is all about. So when we start to think about our software design in this sense, it brings a very different perspective. Now, I say the same thing to security people. If you're going to talk about defending the castles, this is what that means. It means understanding what's most critical that I have to defend, putting that into the most secured area, or however I want to look at that, but then building those defenses around it. So when I talk about this, it's a really simple process. It's identify those assets and threats. For any of you who have heard your security people talking about threat modeling, that's what it should be about. Threat modeling is another one that makes developers cringe because security royally screwed it up. If there's security people in here right now, I know you hate me because I'm beating on security people, but I'm one of them. I take responsibility for this too. But threat modeling should be all about identifying your assets and what those potential threats are. What are the most critical things we worry about, and what can possibly go wrong? Then we translate those into our application assets. Where in the application are those things being touched? Where are those things a part of our actual code base? Now I can start to define those little micro perimeters I'm going to put around them. I can put defenses around those micro perimeters. I can start to assess those defenses, and then it's just wash, rinse, and repeat. When we start to think about it in this way, from a design perspective, this is how we get out of that mode, and we can start to convince our security folks that maybe we don't have to fix every vulnerability right away, so get off my lawn. Stop telling me that I've got to go out and fix 45 new vulnerabilities that your whiz-bang, fresh, new, blinking light DAS tool found, or your cloud native security posture assessment, blah, 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 blah. Yeah, these are great tools. I love them myself. I use them. But those are tools for me. And how I engineer with my developers needs to be different. So what happens then when we come to this point? We've got the disaster. We've got something that comes up. We've got a log4j, or we think we have something in OpenSSL, something we know is going to hurt. Well, This is where we avoid the all hands approach. And I cannot stress this enough. And this goes against so many things we've been taught for the last 25 years that I've been in the tech industry. It's not about all hands on deck. It's about how do I prioritize? So I need to be looking at what is that most immediate attack surface? What is that outer wall? What am I going to do there? What can I do to establish mitigations at that point? I need to start prioritizing. So having a good way to understand and say, based on this attack, these are the applications that are most likely to get attacked. Here's how I'm going to prioritize them based on numerous things, like their likelihood of being exploited. How easy would it be to remediate it? And do I have other mitigations in place? What is the true risk? Because now I can start to look at mitigation. And mitigation is just really about focusing on that strength and not perfection. It could be, hey, you know what? We have a web application firewall sitting in front of all of our web-facing assets, and that web application firewall vendor just released a new detection rule that'll watch for those JIND requests that come in against Log4j. So I'll implement that. That's my first priority. Now from there, I can methodically start to look at those web apps and say, all right, which ones need to be remediated? I can isolate them if I need to. Block it where I'm able to, but make sure I'm logging it wherever I can. And then it's just a matter of repeating this each wall or each classification level in. Look at each layer of risk as I prioritize these into those different classification layers and say, hey, all right, we're done with this one. Now we'll go to the next. But here's the key. When it comes to that remediation, make it business as usual. Consider what the threat vectors really are. Do I care about an insider threat the way I care about someone from the internet who can actively exploit remote code execution? No. Why? In fact, 90% of the time, the reason I care about vulnerabilities on my internal network is I'm worried someone's going to get in from the outside and just use that vulnerability to pivot to other assets. So consider the attack vector and be realistic about it. We need to be methodical, but we need to take our time, take a deep breath, walk through this. And then you can do all the other things that we go along in vulnerability management. Put it in your backlog, track it, have the meetings if you need to have the regular meetings to check in and see how the remediation's going, report that back, make sure compliance is aware, and understand what you can learn from it for next time. So with that, it's about time for me to wrap up. Same quote I left you with this morning if you weren't there, because I love this. And this is such an important lesson. Just perfection is that enemy for progress when it comes to security in particular. We're so worried about getting every vulnerability because someone somewhere once said, well, the attacker's only got to be right once. Well, yes and no. So keep getting better. Keep working to improve. That's how you're going to get more secure, and that's how you're going to keep the security people out of your hair. And in the meantime, I'll be fighting with you to try to keep those security people a little more realistic and focused for you. So with that, one more time, my social media information, I'm more than happy to continue the conversation here, there, anywhere. You let me know. I'm always happy to chat. Thank you to all the talk, or all things open, sorry.